finally, I have something prepared here from back at uni when I was tasked with coming up with a project that was given a bit of a blurry scope, I guess, and it was just had to be something that was quite, I guess, technical in a certain sense. So can everyone see that there? Brilliant. So I'm just basically replaying the presentation here, but we're going to skip past all the boring theoretically stuff because that's probably not very exciting. So what I was researching was about file systems. And so a bit of background, file system, everyone's obviously got one on their machine. It's where your files live and directories and all the rest of it. I'm sure we all have a fair idea of what a file system is. You can also have virtual file systems as well. So that's things like you can have file systems running over a network, and this is similar to things like the Windows Share or Apple Share or FTP or SSHFS or something like that. So you can have virtual file systems as well. They don't actually have to physically live on a disk anywhere. I'm going to skip past some of this boring stuff. There's a whole bunch of file systems basically, and they operate in different ways, but that's all right, we can skip past that. So for Linux, there's a library called Fuse, which stands for the file system and user space. And what that lets you do is it lets you write your own virtual file system driver that runs in user space. You don't have to deal directly with the kernel, which is a lot nicer because you don't really want to have to be doing that. And especially when you're writing C or another low-level systems language, lots of things can go wrong. There's lots of footguns, so you want to try and avoid those. Fuse offers two APIs, a high-level, easy-to-use API at the expense of performance, so it's synchronous and works off path names. There's also a lower-level asynchronous API that works off inodes, which are kind of what files are really made of. So, don't know what that was. So there are some kind of esoteric file systems out there. So there's one called PyFS, which is it's based off the number pi. So basically, because of the properties, mathematical properties of pi, how you end up with a seemingly random sequence of digits all the way out, all data will be present somewhere in pi. So actually, you don't really need to store the data itself. You just need to store the index in pi at which your data lives. And so there's a file system, a Fuse-based file system based off this. You can install it, you can run it yourself. It's extremely slow, as you can probably imagine. It does split your data up a little bit into, I forget what it is, it might be like 100 bytes or something like that, and then it just stores the indices of each of those 100 bytes, because otherwise it'll be looking for a very, very long time. But once you've got the indices, it's actually really fast to pull these numbers out, relatively fast. There's another one here called PingFS, which offers true cloud storage. So if you've been familiar with the ping tool on computers, what it does is it sends an ICMP packet to a remote computer and waits for a response. And that can actually hold arbitrary data as well. So the idea is to store your data on in one of these ICMP packets, and it will just get bounced around routers and remote NICs and other computers and everything, and eventually it'll come back to you, at which point, if you don't need it, you just send it back out again. So one of the benefits is actually a slow network for this is actually really, really good, because you've got more storage essentially, because there's more things going on, especially if you've got more intermediate nodes as well. That's just good. So some of the drawbacks is this Fuse-based file system requires root access because it needs to manipulate the bits directly when it's talking to the kernel for the socket. So yeah, that's an interesting one. You can download and run it if you want to. I don't really know why you would, but you can. So a bit of a switch now. So I went to university here down at UC, and they use this the software to manage room bookings within the libraries that they have there. So it's called the meeting room booking system. It runs on PHP, uses MySQL. It's currently at version 1.9, and it's had 35 major releases since 2001. And I mention this because the university is running a 1.0 version of the software, and which is great because it's got a whole bunch of bugs in it, and you can do all sorts of stuff with it. Maybe not bugs necessarily, just undocumented features. So the UC offers about 40 rooms that are bookable. There's actually a few more if you dig around, but you shouldn't. But anyway, it's accessed via HTTP. There's no S on the end of that on purpose. You also have to get authentication to this. It's using basic HTTP authentication. So you type your username and password, and it goes across the wire in plain text, which is just 10 out of 10 security engineering there. But anyway, this is a bit of an aside. So there's a link there to that as well. But so I thought, what if? So I've designed the meeting room file system, which is a Fuse-based file system that stores all of your data on the university's room booking system. And I've written in C, and at the moment, there's actually this, I made this presentation before I actually finished the project. So you can read the files, you can also do directory listings as well at this stage. So that's cool. I kind of haven't really done anything on it since I finished the project, but so there's some challenges here because there are some limitations to what you can and can't do. So there's only one booking per room per day. You can book across different rooms, but they have to be spaced 90 minutes apart. The bookings themselves can't be updated despite there being an edit booking button, and like it brings you to a whole form and you can hit save, but it never works. So don't know. You can store 1,400 bytes of base64 encoded data per booking, so that's actually quite a wee bit. So we actually get really slow read speeds out of this as well. So it takes 1,500 requests to get a megabyte out. So you won't be storing your music. Well, you could, but it would be slow. I don't know. Maybe, yeah. Yeah. So, and the performance is awful. It's the way that we have to do it because we have to chunk these files up. We have to store them in obviously chunks, everything like that. And the way that it does its search to find new booking slots that are available, it's just linear. It's just, this could be optimized, this could be better. There's a reservation and deletion scheme as well, whereby it goes through and finds all of the bookings that it needs to make for a chunk first before it writes the data out, before it writes the file out, and then it will go back and it will overwrite each of these bookings. And because you can't update, it has to delete them and then recreate them. So that's a bit of a security issue right there, because someone can jump in the meantime and put their own file chunk there. So, you know, you could be linking to someone else's file. Where are we? Yeah, it's not great. So this is the so the amount of requests you need to read and write. It's not great. That's a bit boring. What else we got here? So this is kind of exciting. So you've got per person, you've got 430 megabytes, and this is because you can make bookings all the way back to the year 1901. This is one of those undocumented features I was talking about. So you can make your bookings all the way back then. So you've actually got 430 megabytes to play with. Overall, for all users, that's about 45 gigs. So perhaps you could band together to, you know, put a movie on there. I don't know. It would take some coordination, but you could do it. And yeah, so that's the presentation, I guess. So I thought I would show you the room booking system. Can you guys see that still? Yep, cool. So this is today, for example. I still have access to this website. I haven't been a student for years, but apparently I still have access. They're still accepting my plain text username and password, which is great. So you can, obviously this is not very exciting. I made it make bookings all the way back in the year like 1901, because that was, no one else had book rooms then. I don't know why. So if you go to a different day there, it comes up with a whole bunch of information up in the URL, and you can just go in here and you can just type in what you want. So if we go to 1901, and I think it's in like December, and it might be the 14th, I think, is when the bookings start. Can't remember. And the area from memory is not there. I think it might be 226. No, the room is 226. Let me go here anyway, and I think it might be that one. Here we go. So here are my bookings. This is when I was testing the program. So you can see here we've got there's an I for I forget what I stands for. I think I was my designator for an inode, which is kind of like a link to some data, and D for directory as well. And you can like click these and like you can see the booking that it's made. So it's just like base64 encoded data. So you can go and like base64 decode that and oops. Can everyone see that still? I've just changed screens. Yeah. Okay, cool. So there we go. So it's saying that there's, oh yeah, so, and it has encodes a link to the file itself and has the name of the file there as well. So for example, I was just storing the make file that I had for the project in there, and it works. So I do actually have it running in a VM. There's not much to see, unfortunately, but if we run it, cool. So if I go ahead, and so I have a directory called foo. If I want to mount this in the year 1960 on February the 2nd at 9 in the morning in room 226 is what that is saying. So what I'll do is I'll go in here, it'll do that, and what it does is I've made it, it creates a new directory, mounts it, and then uploads a whole bunch of test files, which are just copies of the make file because it's quite boring. So you can go here and you can ls the directory of foo, and there are all my make files. You can also open them, of course. Now this is where you see the performance hit happen because it's not actually that fast. So hit enter and there it is. So it takes a wee second, but you know, I mean, these aren't very large files. These are, oh geez, I've done it now. So now it's going through and statting all the files to get the file sizes. Sorry. So there you go. So like 2K each, these files. And of course, if we go to, what did I say, 1960 in February, where are we? Oh, gosh, 1960, there we go. 1960 in February, day, month, 2. I think that should be right. No, yes, no, what's that done? Oh, I'm in the wrong place. I have to be out in here. Sorry about that, guys. 1960 and February. And there we go. That's my directory that it's created. And it's hasn't created the files here. It's gone back to the year 19 something or other and created the files there because that's just kind of its baseline for making new things when it's not directed at a specific place. But yeah, so it works, and all the rest of it. It's pretty good. It's also private as well because you can't view other people's bookings. So it's, you know, secure, which is nice. Just don't worry about the HTTP and it's fine really. So yeah, that's all I got for you. The source isn't out yet because I committed my username and password to my Git repo and I need to figure that out first, which actually saved me today because I did forget my username and password and I wasn't able to log on to this, but Git saved the day. So there we go.